Yes, because it's kind of complicated for them to understand what an FGS is. And it turns out to be complicated.
Hi, good morning. How are you?
Hello.
We are pleased to introduce Master Dental Technician Madalena, and we are very happy that she is a very good expert in designing the occlusion with Mojo. Madalena Pires is expert from more than 10 years in the digital life, and she is very professional in this business. You hear me very fine?
Yes, I hear you very well. Can you hear me?
Yes, very
Great.
clear.
All right. So, am I on?
Yes, I will give you the hosting.
I'm
so
going to
you can-
share my screen.
Yes.
It says you've disabled my sharing. That's good. So here, share. All right. It's good. Everybody can see my screen?
It's clear, very clear.
Great. Hello, everybody. My name is Madalena Pires. And as the introduction, I'm a dental CAD/CAM specialist. I am a dental technician with many years lab experience, and I've been working in the industry developing CAD/CAM for now 12 years. Currently, I'm working for Mojo. I am a R&D manager, and I'm doing today this presentation to show you a little bit, present the Mojo, and also what you can do with it, especially in Exocad. So I hope by the end of this presentation, you have joined the movement. So, let's see. Okay. So in the Mojo, we are in the business of recording the real patient's jaw motion, and we can also replay the dynamic occlusion. I will explain this in detail.
Link my mouse. Yes, okay, yes, okay.
Is that okay? Do I continue? Is everything okay? Can you hear me? Yes?
Everything is fine. Now we are live. Okay, we can start.
Oh, so I have, it was not time to start yet? So I'll have to go back then. So I can start now? I start now? It's
yes,
good? You can
good.
hear me?
Yes,
So do I start all over again, or did you?
Yes, yes, we are now live.
Okay. Hello, everybody. My name is Madalena Pires. I am a dental technician with many years lab experience. And I've been working in the industry developing CAD/CAM, dental CAD/CAM for now 12 years. Currently, I am Director of R&D at Mojo. Mojo is a French company that has invented and developed a jaw motion tracking device, but that is much more than that, as I am going to show you. We are in the business of recording the real patient's jaw motion, and we can also replay the dynamic occlusion. Mojo is the critical missing piece in jaw function diagnosis, dysfunction diagnosis, It's also in the treatment plan, so it will help the doctor create a treatment plan, and is also the missing piece in the digital workflow. I'll talk a little bit about the digital workflow. So we have the input 3D data. Most of our customers already own an intraoral scanner. We are open to all intraoral scanners. So I could give you examples. A lot of our customers will have a cash stream scanner or an iTero or a Trios or a Pride scan and so on and so on. So all the open, today they're all open intraoral scanners. We can use the data and mostly also in color. Of course, if the dentist doesn't have an intraoral scanner, we can also use the data that has been scanned in a lab. So the models that have been scanned in a lab. This is totally possible. So we offer the function tracking, which is the 4D data. And with this, we're going to be able to do a personalized treatment through the CAD/CAM design. So we are, like I said, we are fully integrated with Exocad. Exocad can read all of our data, but also we have a lot of customers working with dental wings and 3Shape. And I will explain then in the process how we can use our data in those softwares. So I'm going to show you a little bit videos and explain a little bit the device. So it's a high-end real-time optical tracking system with a touch screen. It's inspired also a little bit in animation movies. The Mojo is also an amazing communication device with the patient for the dentist. And it's non-invasive at all. The patient is not uncomfortable. As you can see, he doesn't have like a lot of metal like the traditional face bow and other jaw tracking devices. And the real plus of the Mojo is that we're going to see the movements live. So as soon as the patient starts moving the jaws, we can see them live at the same time he's moving the jaws. We also have amazing feedback from our users about the quality of the rehabilitation and the time that they reduce in fitting those rehabilitations. So here we're going to show you a video about the recording method. So here we glued that little piece of plastic on the lower jaw. We calibrated the tally. Now we put the little stylet, the butterfly, which is the tracking device. And then we mark some points on the face. This will help us create a virtual face bow. We mark some points on the jaws. This allows us not to have a marker like our competitors where you have to put a marker in the mouth and the workflow becomes quite complicated. And as you can see, as soon as the patient starts moving the jaws, we can see in real time the jaws moving in the Mojo software. Now the doctor is going to give the patient a little piece of apple to chew, and we're going to record the chewing cycles of the patient. And like this one, there's many other things we can record, like speech, etc. And this is data that we didn't have before, so it's very new, and it's a real plus in the digital process. Here you can see 3 little videos that show you, for example, how we can do, how we can see the occlusion in color and in motion. So this is after the registration. The doctor can take his time. Once the patient is gone, he can take the time to analyze his recording, to do his diagnosis, and also decide of the treatment plan. We can also import segmented CDCTs. and animated also in real time. So the doctor can ask the patient to perform certain movements to see how the condyles behave in relation to the fossa. This is also data that we didn't have before. It can be an amazing help for diagnosis, especially for people who are in pain, to find very quick where the problem is. We can also import a face scan. The face scan in the Mojo doesn't really have a function, but what is really interesting is that we can position, because we took those references in the patient's face, and sometimes we're going to mark the little points on the face before we do the face scan, and then we can exactly position the face scan without having an extra marker. Again, no complicated workflows, so we really simplify the job of the dentist and of the dental technician. Here, this is a little video to show that we also have protocols for edentulous patients. So what we do here is we scan the whole denture inside out, and this is the data that we are going to use in the Mojo to do the recording, and we're going to glue the little butterfly, the stylet onto the lower jaw and record the patient's movements. And this part I'm going to show you live. So I'm going to close this and this as well. Stop this. It's closed. Okay, I have to share again. I think I have to share again. Share the screen. So now we are in the, so you can see the Mojo software now. It's all good? Good. So this is a very interesting case I'm going to show you. So this is the point where we already recorded the patient. The patient went home, and now the doctor can take the time to do his analysis, diagnosis, and treatment plan. It's a very interesting case where the patient has both of his laterals are missing. He has, as you can see, absolutely no canine contact. Also sort of a little bit of an open bite in the front, and you will see when I perform the movements, he has no canine guidance. So for example, I have here a Farrar diagram, and so I'm going to replay the movements for you. And as we replay the movements, we have the graphs on the right side. I'm going to move this thing over here, over there. And as you can see, we can also see in color how the occlusion behaves when the patient does certain movements. The doctor can record as many movements as he wants. We give him a list of like typical movements to record, like protrusion, lateral protrusions, Farrar diagram, open, close, bruxism, speech, chewing, etc., etc. You can also record your own movements if there's something you see you need and that is not in the list. You can record each movement as many times as you want. And in each movement, you can perform that movement as many times you want. For example, let's take protrusion. For example, let's see here. We're gonna, this doctor recorded 2 times the protrusion of the patient. But it could be 3 or 5 if necessary to, for example, to analyze the stability of the movements. Some patients are going to move, have very clean movements, and some, if they're dysfunctional, once they go right, once they go left, and you can see also where the dysfunction repeats itself to do an analysis and diagnosis of the problem. The Mojo software offers many, many different tools. I'm going to go through a little bit through the tools, so we can of course hide and show all the parts or make them more or less transparent. We have, so here I've already imported the face scan and already positioned this face scan. We have a wizard here that allows us step-by-step, the very easy way to place this face scan with those points, those reference points that we marked while we were registering the patient. We have all kinds of data here, like for example, those are the points that we marked on the face. This is the condyle axis, the bicondylian axis, and we also have the planes, which we call our virtual face bow. So those planes, especially the axis and the condyles, you can also see the position of the condyles, is going to allow us to do a virtual articulation if needed. I will show you that in Exocad how I import this data and position the data in the virtual articulator. We of course can show or hide the courses. Let me, for example, take the speech. Here I am with the, and this is what we call the FGS. I'm gonna hide it now. Yes, I will tell you about it afterwards. There you go. So I'm gonna do speech. And so you can see the trajectories here when the patient moves there, and then the points, the 3 points, which is both condyles and the incisal point that we marked. So here the patient, we are asking the patient to count from 60 to 69 to record the speech. We can also show the data in occlusion, or we have other types of visualization, for example, like this. If we are analyzing, for example, this case is quite interesting. We can see that the patient does not have any, for example, with the Farrar diagram, he does not have any canine guidance. So he actually, his guidance is on the posteriors. So you can see here in color when the patient moves, so we can replay those movements that we registered as many times as we want. So this FGS is a name that we gave to the traditional FGP, which means functional generated path. We call it functional generated surface because we turned it into a surface. So if I'm going to show you now, oh yes, let's take, I think we had one for the chewing. So we can create, for example, I'm going to create an FGS for the lower jaw here. So I'm going to click on mandible FGS, and he's going to calculate this FGS. It means that he takes the movements and is going to create a surface according to those movements. As you will see later in Exocad, I can import the real movements of the patient. But in the other softwares like 3Shape and Dental Wings, we cannot. So the methods our clients use, and if they work with a lab that does not have Exocad, is they're going to create this FGS and then import it as an antagonist in the virtual articulator. And this allows them to recreate the real movements of the patient a lot more accurately than if we were just using the virtual articulator. So here, as you can see, this is the full chewing cycle. And it's going to take a little bit to record and to create this envelope, this surface. I could also crop the movements. I'm going to show you this. That's the next thing I'm going to show you. So as I said before, we could record 50 chewing cycles, but we're not going to need all of them, neither to do the FGS nor to export to Exocad. So the software, the Mojo software, allows you to crop just exactly what you need to send to the lab to create, if it's a correction splint or a prosthetic device, and we're going to be able to use the real patient movements. So now I'm creating the FGS, it's almost done. And I'm also going to show you how to define the angles. So there it is. This is your FGS. So this is a surface that we can export in STL. So this STL, then we can import it as an antagonist in the virtual articulator, and so do a dynamic adaptation that's a lot more advanced than just the movements of the virtual articulator. Let's see, now for the angles, those are the parameters then for the virtual articulator. With the protrusion, we're going to be able to define the condylar slopes just by clicking here. So you can see here, this patient has 47 on the left and 50 on the right. With the right lateral protrusion, we're going to define the left Bennett angle. And with the left lateral protrusion, we define the right Bennett angle. I'm going to take off those. This is about it for the Mojo software. We have, it's a whole world of tools. For example, I can define an opening of the jaw. If we have to open the patient's vertical dimension, I could, for example, analyze the centric relation. For example, this is the recorded centric relation of the patient. With the centric relation, I can define how the patient really, what his function is. I can see how much I can open the bite before I actually stress the muscles of the patient. And then with the opening and closing movement, open and close. So I said, okay, I decided through the centric movements that I want to open this bite by 2 millimeters. So then I'm going to perform the open close several times, and I'm going to see here the patient stabilizes and he's in a vertical, and it's usually we choose a closing movement. And then we also have the frames. And here we have, for example, a 2 millimeter opening. We could now record this position and export, create a new consultation where all the movements that we register are translated to this new position. And so the doctor would at this point export data to the lab already with the correct opening. And I think that's about it for the Mojo software. So we have several types of exports. Let me just show you how to, for example, crop a movement. Let's say the protrusion. Here we've recorded 1 and 2 protrusions. So I can choose which one is the best to use for the to make the prosthetic. And so I can choose this like that. So I'm not sending too much data to Exocad. This here. And then by cropping, I create a new movement. I can also change the name of this. And I'm going to call it new, for example. And then you will see what happens at the export. So now I have 3 types of export. The Mojo export allows us to exchange Mojo projects between Mojo users. So we have also more and more labs who want to have the software because maybe the dentist doesn't have the time, or has done an export, but maybe something is missing, and they prefer to receive the whole project and make their own exports. So this must be, of course, a lab that is very skilled in digital dental softwares and knows what they're doing, so they'll be able to work with this. So the dentist could send them the whole project, and the lab could now do their own exports. The in-motion export, we are going to see all the movements that we registered and cropped. For example, here, I have the protrusion, the left lateral protrusion that I already cropped, the right lateral protrusion. I will take off this old protrusion because I have a new one. I have the last chewing cycles that I also cropped, and I don't want any other of this. I don't need this for Exocad. None of this is needed. And so I'm just going to export the movements that I need: right and left lateral protrusion, and some chewing cycles. So this is what's beautiful about the Mojo, is that it's an amazing diagnostic device. So the dentist can record as many movements as they want and they need to do the diagnosis, but we don't need all of that for the CAD software. We're only going to need certain movements to make the prosthetic device. So we can just crop and take only what we need. And I would export, for example, now I've already created an Exocad project, and it's already indicated here. So I'm going to export everything into the Exocad project. I can also create a new folder in here and call it dynamic. And it's done. Done. There you go. We also have, so the static export, and the static export is going to be what we call the virtual facebo. And additionally to the virtual facebo, we also have the occlusal curve that I forgot to show you. We actually create as a patient-specific occlusal curve, so in relation to the registered movements, and we're going to use what the French and the German call a calotte, which in English is called the curve of Spee-Wilson. It's a huge help also for edentulous patients or patients that have a lot of missing teeth. For the lab, this is a great indication to know where to position the teeth. If I hide maxilla, you're going to see this curve is very well positioned in relation to the patient's occlusion, and it can also indicate if there is if this occlusion is uneven. A lot of times because of old bad prosthetics that were not well adapted, where we didn't have this kind of data, and so we could correct that and create an occlusion for the patient that's going to be a lot more functional and comfortable for the patient. So this is the static, and I already recorded the static. Can you see my Exocad Dental DB now? Is good, or yes?
Exocad is not open yet.
No, so I have to share again.
Okay.
When you share, let's with Exocad. Exocad.
Yes.
So it's
okay.
see?
Yes.
Okay. So as you can see here, I've already created an Exocad project. We're going to redo this gentleman's front teeth. And here I have the dynamic data, the static data, where I have I have all of this data, including axial orbital plane, camper plane that's going to help me position. And we export all of this already in the correct position in Exocad. So what I'm going to do here, I'm going to cheat a little bit, and I'm going to rename the upper and lower jaw so that it will open automatically in Exocad. Lower jaw, and then initial upper. So I name it according to the dental project and call it upper jaw or lower jaw. So now we have here the lower jaw and the upper jaw with the same name as the dental project. This is going to make the software think that I've scanned directly. And since we know that our data is in the correct position in Exocad, this is not going to create any problems. And the advantage is that we don't have to redefine, import the data manually, because in Exocad, when we import external data manually with the import wizard, he forces us to change the coordinates. So we don't want to change the coordinates. And as you can see here, I'm going to go to tools in expert mode, and I'm going to import our virtual Facebook. With generic visualization mesh, I go and I'm to, let's put it in details. So we have the initial jaw with the axial orbital plane, the camper plane, and the occlusal plane. Those three files are going to be a big help. And we're going to keep them individually. I'm going to say, okay, as you can see, they're perfectly matched, all in the same position. And when I go back to Wizard and start the virtual articulator, you will see that the data is already perfectly positioned in the virtual articulator in Exocad. It says it has a little bit of intrusions. It's okay. I'm going to use a BioArt adjustable.
1 minute. We only stock on the database. We are not seeing the design. Can we repeat?
So right now, at this point, I open the virtual articulated data. So as you can see here, this is our or what we call the virtual face bow. Can you see now?
No, not able to see.
Is it
Only the CAD database.
Because it switches software, and so I have to share every time. Sorry about that. So here we go. Now you can see it?
Yes, now.
Okay.
Okay.
So now I opened or what I call our virtual face O, which is, so we have axial orbital plane, which is usually parallel to the upper branch of the articulator. We have the camper plane. We have the sagittal plane that will be perpendicular to the axial orbital plane. And we also have the condyles. And as you can see, this is all perfectly positioned in the virtual articulator. If I make my virtual articulator a little bit transparent, you're going to see that the condyles are perfectly positioned in there. Now here I will open the data. It's back on. There you go. So now you can see, you're going to be able to see our condyles. As you can see, our register condyles are there. And this is just a perfect position in the virtual articulator. As you can see, here's also where you're going to see the limitation of the articulator. This is a very sort of big gentleman with a large face, and of course his condyles are going to be way wider than the condyles of the virtual articulator. Anyway, why do we need the virtual articulator still? And a lot of times we still use protocols where we're going to use the virtual articulator, because a lot of the patients we're going to record are at first extremely dysfunctional. For example, you will ask them to do a protrusion. They can barely do that. They can barely maybe open. They're maybe in a lot of pain. So the patients are going to be very difficult to register the real function. So we register what we can, maybe a few chewing cycles, which is usually, you know, it's a survival thing. Everybody, even if you have jaw dysfunction, you found some sort of way of chewing food. And we're going to record what we can. We're going to do the setup in the virtual articulator for either a correction device or so to re-educate the patient or relieve the pain. Or then if it's, for example, an edentulous patient, imagine we have a patient, he only has 2 teeth left on the top. He's going to have a hard time, you know, doing having a normal function. So we're going to set up all the teeth in the virtual articulator, maybe use afterwards maybe the few chewing cycles to do the finishing, but we're mostly going to use this virtual articulator. Now I'm going to show you how to use the parameters that we, I don't know if I'm going to have to share my screen again. Can you see the PDF? Can you still hear me at all?
Yes,
Okay, you can see the PDF. So for example, with this data now, I can change the parameters of the virtual articulator. So here, for example, on the Bennett angle, I'm going to have 9 on the left, 9, and 2. And on the condylar angles, I'm going to have 47 on the left and 50 on the right. Okay. Then I can also, for example, those adjustable articulators, I can also adjust this incisal table. And this is, of course, essential for a edentulous patient, a patient who has no teeth left. We are through the analysis, through the jaw motion and Mojo analysis, the dentist is able to define how to set up this incisal table to recreate a good function for the new prosthetic device. So once we've done that, we're going to start the virtual articulator. And so we are much, much closer to reality than if we were just importing the data randomly without any indication like we mostly do. So this is quite revolutionary because it's an easy way to record this data and send it to the lab as well without making the patient uncomfortable. And it's a lot faster than a faithful registration. So now I could use this, as maybe some of you already know, the virtual articulator of Exocad. I can now, at any point of the design, I can recreate the movements, check the movements, and also do a automatic dynamic adaptation. Now I'm going to show you how to import the real jaw movement. So the idea would be, at this point, I positioned the teeth. I did a first dynamic adaptation with with the articulator movements, and then I'm going to do a little bit of finishing with the real jaw movements. Qu'est-ce qu'il y a? Non? Je suis en plein dedans. Vous voulez me déranger? Sorry. Now I'm going to open this XML that we exported into dynamic data. So here is our XML. It's called Exocad. We open that. So here we have the movements that I exported into the XML. I can now decide that I want to register all these movements to do an automatic dynamic adaptation, or just a few. So in this case, I want them all because I cropped them well. So you can see it's not too many movements, even though the chewing might be a little much. So I'll just stay with the right, left, and protrusion. And I'm going to then perform, this is basically in Exocad, the same process as the virtual articulator, except that I'm using the patient's real movements that I recorded, cropped, and exported from Mojo. So now he's doing the recording of those movements, so that once we position the teeth and do our design, we can, with one click, adapt to the antagonist in a dynamic way. Meaning it's going to cut all the intersections, but it's also going to cut everything that's in the way of those movements. And it's done. Exocad also creates those virtual imprints on the upper and lower automatically. The most interesting function so far is if you really need to finish the job by hand and you want to open this in a real articulator, I mean, articulate the models properly, you can use this FGS to create a model as an antagonist. So you could use, as everything in Exocad is open, so those what in Exocad they're called imprints, we call them FGS. Those surfaces can be exported as an STL, and you can use this to make a model with the model creator, and then articulate in the physical articulator. So there's many ways of using this data, if it's digitally or even just traditionally with the traditional methods. There's still a lot of dental technicians who finish everything by hand. This is we make custom-made medical devices. There's a lot of, when we go into, for example, anterior teeth, there's a lot of finishing to do by hand that the machines cannot do. So we have a lot of solutions here to use the data till the end. Now, for example, I can go next. I can keep this open at any point. I can re-record or redo any of this data, replay any of those exported movements. And now I'm going to position the teeth. So just, and at this point, maybe I'm going to go to Expert, Tools, and open the face scans. So the face scan is already been exported in the correct position from Mojo. And so all I have to do now is open it. And it's been exported in the data in the correct position. As you can see, I have now all this data to position the teeth and make, I call this a smile simulation, because smile design is a specific protocol with 2 pictures, but we can do some really great work already with the face scan. A lot of labs, digital labs out there, are very happy to use the face scan. How am I doing on time, Rasam?
You are free. You free time.
Okay, so is it 3:41 already?
Yes, you have about 20 minutes.
Another 20 minutes more?
Yes, you have time.
So
We
I'm going
finished. Oh,
to position the teeth.
yes.
Position the teeth. As you can see here, the color means that Exocad has all sorts of tools to analyze also the occlusion. Here I can have, this thing is in the way. I cannot click on the dynamic. We have a dynamic and static visualization. And I'm going to position this a little bit better. In the next step, I can do a little bit of chain mode, and then I'll be pretty much done. Let's put the true smile to make it a little bit nicer. Let's position teeth. So we could, for example, in this patient here, we could recreate the canine guidance if the doctor wishes so, of course, and if it's prescribed. If this is going to help the patient, relieve them of pain, etc. So as you can see, as I move the teeth, the colors change. It means it's an indication immediately to position my tooth. And I know that if I do a dynamic adaptation, all those parts are going to be cut. They cut and adapted. So not going to take too long. And here I'll show you the tool in Exocad that allows us to do the occlusal static or dynamic adaptation. So static, it's going to only cut the intersections in a static mode. Means if there was any intersections with the antagonist, here he cut it, which there's not because he has an open bite in the front. And if I do a dynamic adaptation now, if I did cut intersections, as you can see, it cut all the movements that were in the way, all the parts that were in the way of the movements. So now I can, for example, freeform according to the patient's natural movements. So I could now make so nice teeth according to the movements, and I can always come back to the adaptation wizards tab and readapt those teeth. And so that's about it for my presentation. Apparently there is a question and answer part. Does there anybody have any questions?
Yes. One question about the face scan. We can import and make the mouse open by the other software or with Exocad to make the lips open between the upper lips and lower lips. We need to use another software to deal with the 3D scan of face scan.
Face scan, yes, face scan is 3D data. So at this point, they're all external. There is now certain devices, for example, like the Carestream CBCT, the latest, the 9600, that offers a face scan while when you do the CBCT. And most people right now in dental are using several like apps and things that they can add to their tablets and phones so they can quickly scan the patient. The advantage of Mojo is that it's completely open. So we will take any format, PLY, OBG, any open format. You can import the face scan, position the face scan in the Mojo, and then when we open it, it's already in the correct position. As you can see, this is properly positioned. Now, what I usually do Stick is in the way, is that I'm going to smooth a little bit this part here. The teeth are always very, very deformed in the face scans. So what we do is that we have other ways of position, and then we go and cut those teeth to do our smile simulation with the face scan. See, I can delete, and now I have the teeth and the jaws. See, now I can position this teeth, go back to Wizard and position this teeth according to the patient's face. And plus I also have all of those references that will help me do a smile simulation. Plus, if I'm setting up a whole jaw, I also have this calota, this curve of Spee-Wilson, that allows me to see where the patient's occlusion is. For example, if I was doing the full jaw, take off the antagonist and show the calota, I could position the teeth according to this curve of Spee-Wilson. I hope that answers the question. I'm not sure I understood the question well, but I thought I did the whole went around the subject.
This template of Wilson and is it coming from Mojo or it's from Exocad templates?
I don't know. I don't understand the question. What templates?
Wilson and this template of the occlusal plan is coming
yes,
from.
Of course, it's a patient-specific Mojo export. So with the Mojo I showed earlier, we can create that sphere according to the patient registration. So this is a patient-specific calota. And that has been exported from Mojo in the correct position according to the jaws and all the other data and the face scan to Exocad.
So Mojo is software and hardware, two parts.
Yes. Mm-hmm.
We need the tools to like Butterfly to make this registration, and we can with the software record the movement and export to the Exocad. This is very interesting tools because it's very correcting for full arches cases. It's the perfect way to get the exact movement of the patient's
Yes.
occlusion.
And we have amazing feedback from our users who tell us they are really, really reducing their chair time when they get their prosthetics, especially on large restorations on implants. Already the try-in has very little adjustment, and the final restoration has almost no adjustment at all in the mouth.
Perfect. It's very amazing tool, and it is very helpful. I feel that every dentist must follow these protocols. And about the articulator, there is special articulator compatible with the Mojo, or it's open for any type?
It's open for anyone. So any articulator I can show you here in the tools, in the articulator wizards. We have a whole collection of articulators. As you can see, all of those can be used. And for example, if I open the Modjaw articulator, you're going to see the data is exactly the same, also in the same place. And our virtual face bow is perfectly also positioned in any articulator.
Super, very interesting.
We are also working on being able to print the models already articulated with the different articulators so that the dental technician can also then physically articulate the models and do the final finishing, because we are still doing a lot of manual finishing and a lot of veneering at the end with porcelain. So this could be also a great tool for the labs that are not not yet 100% digital.
Very interesting. Super. So we can also print models and fix in the articulator in the same position that is in the Exocad software. So we
Yes,
can.
we're working on it. We'll probably already showed it in the last IDS, and we would like to release it for the next IDS. Let's see if we can do it, but it's a work in progress. We are really in the business of finding solutions for the dental professionals, if it's on the dentist side or on the dental technician side. And our hope is that Mojo will become also a bridge between the clinic and the lab, and also a communication tool. So this is how the direction we want to go. Also, the idea of digitalizing the patient. It's also the concept of Christian Coachman, where he talks about digitalizing the whole patient. So the first time the patient comes, we take pictures, we do the face scan, we scan the jaws, and we're going to record the patient's motion. Maybe if it's a young patient, we're going to record their healthy function. And if that patient, if one day has an accident or something, we can recreate a device that has their healthy function. So that's the whole concept of Mojo.
Amazing tool, and thank you very much for sharing this beautiful information with us. And wish to make a live courses in on site in Dubai in the near future with Mojo after the Corona. Yes,
Would love to. Thank you so much for having us.
thank you very much,
Bye.
Ms.
Bye.
Madalena Pires. Bye bye. Thank you. هلا أنا بانتظار المحاضرة القادمة اللي حتكون للرائد في تقنية تخطيط الابتسامة، مؤلف كتاب Aesthetic Dentistry، أشهر كتاب في موضوع التخطيط للابتسامة. دكتور ماورو فرادياني، عنده أكاديمية اسمها فرادياني أكاديمي. الدورات عنده أسعارها رائعة، يعني بتقنيات متقدمة وبرسوم تقريبا توصل الدورة في إيطاليا حوالي 4000 يورو للأطباء، وأشهر الأطباء في العالم حضروا دورات عند ماورو فرادياني. شخص دقيق جدا وأعماله رائعة جدا. عنده هلأ حاليا ابلكيشن لتخطيط الابتسامة بطريقة منهجية وعلمية ودقيقة جدا. الابلكيشن اسمه GET، بيشتغل على الايباد. بإمكانك تعمل فيه صور وتحليل للابتسامة وتحريك للأسنان لتحصل على دياغنوستيك رائع جدا. راح يكون كمان عنده دورة في 7 نوفمبر. الدورة راح تكون دورة عن تخطيط الابتسامة بتقنية باولو ماورو فريدياني، الرائد في مجال تخطيط الابتسامة. شخص دقيق جدا. إن شاء الله راح تكون محاضرة مفيدة جدا. We invite Dr. Mauro Frediani, the expert and the editor of the aesthetic dentistry. He is one of pioneers in this smile design, and he is the creator of this science. He is very specialist, and he has academy, Fradiani Academy. He also invent an application to diagnostic the smile in a professional way, step by step, to get a perfect goal result. ليش ما تحط
And again, why